So last time we did this Bessel second kind of Bessel functions जिनको हम Newman functions बोलते हैं, right? Now today we are going to do a few problems, or I can say an exercise. Uh, like we have to prove the recurrence relations for those Newman functions. Now we have to prove that the Newman function yn से जिसको हम represent yn of x satisfies the recurrence relations. दो recurrence relations हैं. The first relation is we need to prove these are the similar kind of a recurrence relation which we proved for the Bessel functions of first kind. So we are actually going to exploit those recurrence relations in order to obtain these recurrence relation. I will show you how. I will show you one of them, and the second you can do it yourself. Like I have the first of the recurrence relation is yn minus 1 of x is equal plus yn plus 1, this is plus n plus 1 of x is equal to 2n by x yn of x. This is the first one, and the second one is yn minus 1 of x minus yn plus 1 of x is equal to twice yn prime of x. We have to prove these two reconciliations. I will show you the one, and the rest of the second one you can prove it yourself. See, now you already know that the reconciliations for the Bessel functions of first kind are two of the reconciliation. Since we know that the reconciliations for Bessel's function of first kind are, ये एक रिलेशन थी वहां पे jn minus 1 of x plus jn plus 1 of x is equal to 2n by x jn of x. ठीक है? If you will go back to your previous lecture, you will see that we have solved this kind of, we have obtained this this jn minus 1 and jn plus 1 is always given by this, and the next one is similar, jn minus 1 of x minus jn plus 1 of x is equal to twice jn prime of x. ठीक है? Now what I will do, I will just replace n by minus n in this equation and also in this equation. So replace n by minus n. So when you replace n by minus 1, what will this equation? This equation will be like j minus n minus 1 of x plus j minus n plus 1 of x will be equal to this minus n by minus n, that is minus 2n by x j minus n of x. Okay, and the second one will be j minus n minus 1 of x minus j minus n plus 1 of x is equal to twice j minus n prime of x. I hope it is okay up to this point. Also, from the last lecture, you know that we know that the Newman function yn of x is given by cos of n pi j n of x minus j minus n of x from the last lecture divided by sine of n pi. So what I will do, I can obtain the yn plus 1 and yn minus 1 from these two, from this very equation. So what is yn plus 1 then? yn plus 1 किसके बराबर होगा इसमें? So it will be cos of, just replace n by n plus 1, cos of n plus 1 into pi j n plus 1 of x minus j minus n minus 1 right? Minus n minus 1 of x divided by n plus 1, that is sine of n plus 1 into pi. Okay, similarly, what is n y n minus 1? Just replace n by n minus 1, it will be cos of n minus 1 pi j n minus 1 of x minus j minus n plus 1 by sine of n by n minus 1, that is sine n minus 1 into pi. Okay, so therefore j of sorry y of n plus 1 of x plus y of n minus 1, इन दोनों को मैं ऐड करूंगा, n plus 1 and n minus 1, right? So this will be equal to shabash, this cos of n plus 1, cos of n plus 1 pi j of n plus 1 of x. I will not write you now x, I will simply write j n plus 1 minus j minus n minus 1 divided by sine of n pi plus cos of n minus 1 pi j of n minus 1 of x minus j minus n, sorry minus n plus 1, x लिखने की जरूरत ही नहीं है यहाँ भी, divided by sine of n minus 1 into pi. Is it okay? Do you understand up to this point? Hmm?
Sir, first sign up n plus 1 pi
n plus 1
denominator में.
हाँ, yes, n plus 1. तो ठीक है ना?
The denominator में n plus 1
the
यहाँ पे
denominator जी sir
sin of n plus 1 into pi. Yes, you are right. बाकी से ठीक?
Yes, sir.
Okay, very good. So now see what I will do. I will add this. I will cos of n plus 1 into pi, that is cos n pi, cos of n minus 1 into pi, that is again cos of n pi. So I will write down these two terms separately and these two terms separately. So let me write it on the next page. आप लिख रहे हो साथ साथ अपनी कॉपी पे?
जी sir
Yes, sir.
Okay, then I will write it here. So what I will do, I will just from that very step, I will write down this as cos of n pi. Now taking this two j n plus 1 plus j n minus 1 term divided by sine of n pi. एक तो ये वाली term मैं लूंगा यहाँ पे. So यहाँ पे cos of n plus 1 is cos n pi j n plus 1 plus cos j n minus 1. These two terms. Now divided by sine of n pi, n plus 1, this is sine of n plus 1. Now from this very term j n plus 1, and now I'm going to write down these two terms, the second term from here and the second term from here. But what I will do, I will take the minus sign bahar यहाँ पे. So I will write down this is plus j of minus n minus 1 plus j of minus n plus 1 divided by sine of n pi. ठीक है? Because sine of n pi जो है, that I will write down as minus sine of n pi. That minus sign term will get cancelled out with the minus sign in the numerator. Okay. Now I already have obtained jn plus 1 and jn minus 1. What is this equal to? jn plus 1 यहाँ पे jn plus 1 कहाँ गया? jn plus 1 and plus jn minus 1. This thing, right? ये जो यहाँ पे है ये वाला. So what is this? What will be this equal to then? So this will be cos of n pi. Cos of n pi. Instead of this, I will write down this as 2n by x. 2n by x jn, right? Divided by sine of n pi. Okay. Plus now j minus n minus 1 minus n plus 1 divided by sine of n pi. I also have obtained all this j minus n plus j minus n plus 1. This is minus 2n by x j minus n of x from this equation. This equation. Okay, so you will write down this as plus minus 2n by x j minus n divided by sine of n pi, right? Okay, or you can write this as 2n by x अगर मैं बाहर ले लूं, so you will write down this as 2n by x अगर मैं बाहर ले लूं, so we will have cos of n pi jn plus minus j minus n divided by sine of n pi, and you know that this is equal to, so this is 2n by x y n of x. So this was the first reconciliation, right? That is y n minus 1 of x plus y n plus 1 of x plus is equal to this thing. So this is the first. Now see, I am, you have to do the second one yourself. I'm just giving you some hint. Now the second one is y n minus 1 of x minus y n plus 1 of x. Just there is a difference of minus sign, and we have to prove that twice. Sorry, this y n prime of x. Now for that we are going to use the second relation reconciliations. वो second reconciliation क्या है जो बेसल फंक्शन ऑफ फर्स्ट काइंड की है, j n minus 1 of x minus j n plus 1 of x is equal to twice j n prime of x. So what you will do now? Now you again you will just replace n by minus n and n by n plus 1. So then you will see कि आपको कौन सी आप इसमें जरूरत पड़ेगी, ठीक है? करोगे ना ये?
जी सर।
ये आसान है, जस्ट फॉलो दो स्टेप्स. फॉर एग्जांपल यहाँ पे आप वाई एन लिखोगे इसी तरह से, cos ऑफ एन पाई जे एन ऑफ एक्स माइनस जे माइनस एन डिवाइड बाई साइन ऑफ एन पाई. उसके बाद क्या करोगे, रिप्लेस एन बाई एन माइनस वन एंड एन प्लस वन, फिर ये दोनों लिखोगे, एन माइनस वन वाली टर्म वाई एन माइनस वन टर्म वाई एन प्लस वन टर्म, फिर दोनों को ऐड करोगे. जब दोनों को ऐड करोगे उसमें फिर आप में एक में आपकी ये टर्म आ जाएगी, दो में, तो देन यू विल सबस्टिट्यूट द वैल्यू एंड यू विल सी दैट दिस विल बी इक्वल टू दिस थिंग. ओके, ये लोग ये लेकिन कर लेना, दिस आर वेरी इंपॉर्टेंट रिकंसिलिएशन, टू डिफरेंट रिकंसिलिएशन, दे आर नॉट सॉल्व्ड ऑन द बुक, दे आर नॉट इन द एक्सरसाइज. ओके, so shall we move to the next thing?
Yes, sir.
एक second. Okay, now the second thing is what we call as an Hankel function, or we also call them as a Bessel functions of third kind. We are not going to study in depth, just I'm going to give you an idea about these Hankel functions and why do they arise. Because its proof is very complicated. You need to find out, you have to find out, just to take the combination of both first kind and the second kind. I will tell you some important things about this Hankel function. Hankel functions, because these Hankel functions are very rarely used in your course. So this actually, these Hankel functions actually are the solutions of Bessel ordinary differential equation. यानी ये भी one type of जो Bessel equation होती है हमारे पास. So these Hankel functions, जैसे Newman functions, are also the solutions of Bessel ordinary differential equation. Ordinary differential equation. हाँ हेलो, मैं क्लास बकरे पर वही वाले फोन है ना, क्लास doing. Okay, so are the solutions of Bessel ordinary differential equation, right? But what kind of a solution? With asymptotic properties. ये mentions asymptotic properties. You know what I mean by the asymptotic properties क्या होती हैं? क्या होता है asymptotic? आपने पढ़ा होगा ये asymptotic properties आपने पढ़ा होगा, थोड़ा बहुत आइडिया होगा आपको. That means अगर for example हमारे पास कोई function है, how the function will behave, that it is actually the limiting value of certain function. How the function, for example अगर मेरे पास कोई function है f of n, how the function will behave if n will tend to the infinity. So that I mean by the asymptotic behavior, right? समझ रहे हो बात को? यानी it is actually the some representation, yani the limiting value of some function, yani so these Hankel functions are solution, they are the solutions of Bessel ordinary differential equation, but what kind of a solution with which have the asymptotic properties. So this kind of a thing, these asymptotic properties that makes them very useful in the problems, so I will write here, makes them, this Hankel function makes them useful in problems involving propagation of the spherical or cylindrical waves. So these Hankel functions are nothing, they are just the solutions of Bessel ordinary differential equation, but to that particular Bessel differential equation which has an asymptotic properties. So this kind of a thing makes them useful in problems where we have the propagation of spherical or the cylindrical values. Now we can obtain this Hankel function from the already the solutions of the Bessel ordinary differential which we have found. So since we know that the function Jn, since this Jn and Yn form the complete solution of Bessel ordinary differential equation, right? You know that the solution to this is a Jn of x plus y bn of x. So the Hankel function must be a linear combination of these solutions. So जो ये Hankel function है, Hankel function is a linear combination of the solutions already found. जो हम solution already Jn और Yn, so this is a linear combination of those things. Right? So how we will define? We are going to define this. We define these Hankel functions as, we define them as like Hn1 of x, right? So this is equal to Jn of x plus iota Yn of x, right? And Hn2 of x is always given by Jn of x minus iota Yn of x. So these are the Hankel functions. There are two different functions. One is like a plus iota b, and other is a complex conjugate a minus b. So we obtaining them from the solution which we have already found, and first and the second conditions. So also these Hankel functions are also referred to as the Bessel functions of third kind. Bessel functions of third kind. Okay, once is Bessel function of third kind. So these Hankel functions are actually analogous to, they are actually analogous to, you know that e raised to power plus minus iota theta is always given by cos of theta plus minus iota sine of theta. So what it does it mean? It means that Hn of 1 and Hn of 2, they are just simply the complex conjugates. Right? They are the complex conjugates. Now how we can obtain this Hn1, how we can have the series expansion of these the solutions? We can have the series expansion by using the already found this series expansion of Jnx and the series expansion of yn of x, right? Now you know that how is jn of x given by, if you go to the Bessel function of first kind, you know that this jn of x is given by summation some s running from 0 to infinity minus 1 raised to power s factorial gamma of n plus s plus 1 x by 2 raised to power n plus 2s. याद है ना आपको? jn is given by this thing. ठीक है? This is the case when nu is not equal to minus 1 minus 2, and the yn of x, yn of x, what I'm going to write here, I have not showed it in the previous class because I left it where I found it like 1 by pi yn of x मैंने कहा था this is equal to 1 by pi partial j n by partial nu by partial nu plus minus 1 raised to power n partial j minus nu by partial nu. याद है ना? अब इसके बाद फर्दर जो इसको है, इफ यू विल एक्सपैंड इट, यू जस्ट गो थ्रू द अरफकिन, आपके पास अरफकिन बुक है, go through the how he has obtained that particular proof and what he has obtained, so that I'm going to write it here directly. He has not also obtained the proof, but that proof I need it here in this case. So after this particular step, he is actually making certain assumptions by which he can have the series expansion, because you know that the second solution मैंने आपसे कहा था, this yn of x is always given by ln jn of x plus summation some m running from 0 to infinity, r running from 0 to infinity cm x raised to power r plus m. याद है ना? So this yn, the second solution, is then given by, once we obtain it from this particular equation, I am going to write it here directly, 2 by pi jn of x, and we have gamma plus ln x by 2, right? This thing minus 2 by pi, this term corresponding to this particular y and x is equal to ln jn of x. So this is jn x, ln of x comes from this 2 by pi gamma ln pi by 2. So minus 2 by pi summation some k running from 1 to infinity minus 1 raised to power k factorial into k factorial. This solution I am going to obtain it from the cm x raised to power m, right? hk x by 2 raised to power 2k. You have to remember it like this because it's to find the proof is little difficult. Okay, so this is so the Bessel function is given by this, and the second solution is given by this. Okay, so there are some things which you need to know. So ये hk जो यहाँ पे है, this hk is harmonic number, इसको बोलते हैं harmonic number. This harmonic number is always given by summation m running from 1 to k 1 by m, or I can say that m raised to power minus 1. And this gamma जो यहाँ पे है, this gamma factor, this gamma is the Euler Mascheroni, CHERO Mascheroni constant इसको हम बोलते हैं. और ये गामा किसके बराबर होता है? This gamma is always given by gamma is equal to limit n tending to infinity summation over m running from 1 to n m raised to power minus 1 minus ln of n, log natural of n. So this is called, this factor is called as Euler-Mascheroni constant. Okay, so this is a series expansion of jn of x. This one we already have found, but this I'm going to, I'm writing it here directly. I'm not obtaining it, but you can go through the book, you can find out the proof how he has obtained this value. So yn of x is actually obtained from this very equation. I had explained this. If if n is not an integer, the second solution can be given by jn of x, ln of x, and summation over this. So from this very particular equation, we can write down the second solution like this. Then we know that जो हमारे पास Hankel function है, Hankel function hn of 1 that is given by jn of x plus iota yn of x, and this hn of 2 जो है second kind of function, that is jn of x minus iota yn of x. So combining these two, the proof is actually a little complicated. You have to expand, write the expansion of this term, then expansion of this term. So only few of the terms is of interest. So we are not actually interested in all the terms. The terms which we are interested in, I am going to write those terms only. So the terms which will come from these two. So the one will be like h0 1 of x yani n corresponding to n equal to x. So this will simplify, it will be I 2 by pi ln of x plus 1 plus iota 2 by pi gamma minus ln of 2. So corresponding to n equal to 0, we will have these terms. We will have some other terms, but we are not actually interested in those terms. So from this thing, how I can generalize? So I will say that hn 1 of x is then given by minus iota gamma n by pi, gamma n by pi 2 by x raised to power n plus so on. It's little difficult to understand how I have write it, but you need to remember that we have the expansion. You just remember it for this thing. Okay, similarly, so when I have the expansion, h2 of 0 of x is then given by minus I 2 by pi ln of x plus 1 minus, because we have the second term, we have the minus term, it will be minus iota 2is pi 2s pi gamma minus ln of 2. So the difference between this and this, because this is a complex conjugate of this particular term, so one will be positive, other will be negative. Similarly, so hn of this hn of 1, sorry, this is not 0, this is 2, h0 of 2. So hn of 2 will now be equal to similarly the complex conjugate of this, so it will be gamma n by, replace iota by iota plus iota, so iota gamma n by pi 2 by x raised to power n plus some other terms. This is again the case for n equal to 0. Kalpiti na? Kalpiti ce gasan? नहीं है ये थोड़ा, it's little complicated to understand these things, but you don't, we have to actually prove it, we have to find out the series expansion, but I'm just skipping that very part. I'm not going to do that exercise because you need to know some, have some idea about the Hankel functions. So that, just do remember these Hankel functions jo hai, they are actually the third kind of a Bessel functions and a solution to the Bessel ordinary differential equations with the asymptotic properties. So which makes them this that kind of thing makes them useful in the problems where we have the spherical and the cylindrical waves, right? And it's that these Hankel functions are given in terms of as a linear combination of the Bessel function of first kind and the Bessel function of second kind. So एक तो हम hn1 और दूसरा है hn2. So one is jn plus iota nx and second is the n. उसके बाद मैंने क्या किया है, I say that since jnx is given as a power series, जो आपको पता है summation sum m running from this. Also this yn as a series expansion is given by this. Now combining both these two terms, we can have the h0 1 of x and h0 or hn. You can directly write it this. So there will be a large number of terms. Once you will combine all those two terms, if somebody is interested in this, he can do it. He can solve the, he can write down the different terms for jn of x and the different terms from, then just combine. जो लास्ट वाली terms उसमें आ जाएंगी, उनको just first two terms पहले वाले केस में, second terms में. So actually they are only few terms are of interest. So then from that very equation, I can have this I can generalize this hn1 of x is given by this and hn1 of this is given by this particular thing, right? Also the linear, this since these Hankel functions जो हैं, they are the linear combinations with constant coefficients of this jn and yn, they satisfy the same reconciliation. जिस तरह से वहाँ Bessel function of second kind या first kind में reconciliation, they also satisfy the same reconciliation. So reconciliation कौन सी है? hn minus 1 of x plus hn plus 1 of x will be equal to 2n by x. अभी जो हमने उसके लिए prove की थी hn of x. Similarly hn minus 1 of x minus hn plus 1 of x will be equal to twice hn prime of x. Okay, ये बस remember रखिएगा, we are not going to prove it because for that again we will have to some expansion of all these things. So I didn't teach you fully in the Hankel functions, I gave you just an idea about the Hankel functions, and if you remember this part, the some idea about the Hankel functions, that will be enough for you for the time being. ठीक है, because for the you don't need, I don't think you will require these in your course. अगर आपको यहाँ इस कोर्स में कहीं पे भी इनकी जरूरत पड़ जाती, तो I will have teach it fully. फिलहाल के लिए आपको ये जरूरत नहीं है, that's why I am leaving it I'm just giving some idea about these Hankel functions and not going into the more details of these Hankel functions. And also, you do not need to prove these Hankel functions for this reconciliation for the Hankel functions. Now we have the another lecture that is about the modified Bessel functions. But those modified Bessel functions are very important as far as you have some problems in the quantum mechanics and the electrodynamics. And inshallah, I'm going to give you some detailed description about that particular lecture. Modified lecture and spherical harmonics. They are very important. Spherical harmonics I will do at the end. But inshallah, tomorrow in the next lecture, I will teach you this the modified Bessel function. Now we have some minutes left. If you have something to anything to ask or you have some query, you can just tell me. अगर किसी को कुछ पूछना हो, कोई पॉइंट समझ में नहीं आए, I am going to send you a note of this and also the previous lecture, so that you will just how many students are present. अगर किसी को कुछ पूछना हो या कोई पॉइंट समझ में नहीं आ जाए, you can this ना. या फिर श्वास बादली पढ़ी हुई क्या पाएंगे. अच्छा, जरा कोई मुझे बता एब्सेंट कौन है और प्रेजेंट कौन है. who is absent? बुरहान है क्या? जल्दी बता यार, ये डिस्कनेक्ट हो जाएगा अभी. और आप बस इतना ही पढ़ाऊंगा मैं आज.
मैं देख के आपको मैं व्हाट्सएप से आपको टेक्स्ट करता हूँ
नहीं नहीं, अभी बता, मैंने खोल रखा है, अभी बता ऐसे ही.
अर्शिद है सर शायद.
हाँ, ले
अर्शिद
अर्शिद रोल नंबर 1 इज एब्सेंट. रोल नंबर 20 है.
और 14 भी एब्सेंट है सर.
ओके 14 और 17 और 20 है.
20 भी एब्सेंट है.
बस 4 लोग एब्सेंट है ना. टोटल 16 है.
यस सर.
यस 16 है. ठीक है. और जो लेक्चर हो रहे हैं इनको एक्नॉलेज करो, बिकॉज द वाइस चांसलर एंड अदर दे आर जस्ट कीनली वाचिंग कि क्लासेस हो रही हैं कि नहीं हो रही हैं. कितना % आज आपको समझ आया मेरा लेक्चर? मुझे नहीं लग रहा ज्यादा समझ आया होगा. थोड़ा आओ आइडिया.
यस सर थोड़ा.
लेकिन खुद भी लेकिन पढ़ लो. जब तक खुद से नहीं पढ़ोगे इट्स वेरी डिफिकल्ट टू अंडरस्टैंड. हाँ, मैंने थोड़ा सा इसको पूरा एलॉबरेट नहीं किया है, आई एक्सेप्ट दैट, बट दैट इज बिकॉज कि आई डू नॉट वांट यू टू गो इनटू द मोर डिटेल्स. आप अगर जितना मैंने आपको बताया उतना याद रखोगे, दैट इज एनफ.
बेतकी ना लेक्चर रिकॉर्ड अगर तो ये शेयर करियो ऐसे.
यम छुस ब करन शेयर, बट आई नीड टू अपलोड इट ऑन द दिस ना some link, YouTube link. I will
अगर तो गूगल ड्राइव में से करियो यस अस पनन फोल्डर छ तो इसमें करियो तो सो रोज ज्यादा बेटर.
आज वो भी कर लूंगा मैं. ठीक है, आई हैव रिकॉर्डेड दिस लेक्चर्स, आई विल कीप ऑन एडिंग ऑन दैट.
ओके सर थैंक
अपलोड करना लाइक ना टाइम, बिकॉज़ इसमें ज्यादा एमबी है शायद.
यू. यस ज्यादा को ज्यादा इस 7 MB तम.
चलो ठीक है, मैं कर लूंगा.
ओके सर थैंक यू.
ये रिकॉर्ड से वहीं के ना रिकॉर्डिंग पे थी. ओके
यस सर.
ओके.